Welcome to PowerPoint 1.2. So when you're done with this, you should be able to do all of these things. And we'll look at them again at the end, see if you get it. All right. So make sure you're reading Chapter 4, Section 4.3. So grab a snack like a carrot and let's get started. All right. So protons, where are they in the nucleus? They're positively charged, and what they do is identify an element. So hydrogen, right? Hydrogen has one proton. Any element that has one proton is hydrogen. Hydrogen is the only element with one proton. So you might be saying, well, which element has 17 protons? Chlorine. So protons are the identity. It's also called atomic number. It's in the nucleus, and they weigh 1 atomic mass unit. Neutrons, also in the nucleus. What is their role? They help give the atoms mass. The nucleus is the heavy part of an atom. It has protons and neutrons. Neutrons help give it mass, and they have no charge. Electrons, what are they? They are negatively charged particles that are in the electron clouds outside the nucleus. They determine the charge of an atom. If you lose or gain electrons, then the atoms aren't neutral anymore. So electrons determine charge. All right, so atom is a neutral particle. That's why we're listening to Particle Man. So in the nucleus, there are protons and neutrons, and that's the heavy part of an atom. Protons, positive charge, and that is the atomic number of the atom. Neutrons, neutral, nucleus. Also give the atom's mass. Electrons, negative charge. All right, so here we have a nucleus. Look, the positives are protons. If there's 6 of them, 6 protons, then it's carbon. All right. 6 neutrons means that whole nucleus has a mass number of 12, because the heavy parts are the protons and neutrons, and there's 12 total. And then look, 1, 2, 3, 4, 5, 6 electrons, so that the positive 6 protons, 6 electrons, make it a neutral atom. Atoms are neutral. Okay, so what are ions? Ions are atoms with charge. So they used to be neutral, but what happened? Well, we already said electrons are what causes atoms to have charge overall. So if an atom loses electron to be positive charge. So cations are positively charged, and they're positive. See, cat, positive, cat. Oh, look, there's a plus sign in that word. Cations are positively charged ions. So sodium has 11 protons in the nucleus, and this sodium has 11 electrons. So guess what? It's an atom because it's neutral. This sodium has 11 protons in the nucleus, but only 10 electrons. So it's a cation because it has an extra positive charge. That means an electron was lost. Opposite that is anion. Gains electrons to be negative charge. What does that mean? That means that if you have an atom with 7 protons, okay, that's nitrogen, then right now there's 7 electrons. It's neutral because those equal each other. But if you have that same atom with 1, 2, 3 extra electrons, then it's nitrogen with a -3 charge because it's got 1, 2, 3 extra electrons. So how many protons? 7 protons. How many electrons? 10 electrons. So it's got 3 extra electrons, and that's the charge. Okay. So what can you find out from the periodic table? Definitely atomic number. Atomic number is the whole number on the periodic table. Atomic number, whole number on the periodic table. It's also the number of protons. Like we said, identity. 80 protons mercury, 7 protons nitrogen, identity of an atom. You can also find out average atomic mass. Ours says electronegativity on them, the element name, and the element symbol. Atomic number is number of protons. So we can symbolize that in different ways. Here is the general way to symbolize what we call an isotope. So here's the symbol, uranium. Uranium, you can find it on the periodic table. If you can't find the U, you could find the 92 because that's the atomic number, which is the number of protons. Number of protons. Okay. So it's this number, it's called the mass number. And when we name this isotope, we name it uranium-238 because it is not just any old uranium atom, it is a uranium atom that has a mass number of 238. So that means it has 238 total protons and neutrons added together. Now, charge goes on this side symbol. No charge here. What does that mean? It means it's neutral. Okay, that means protons, 92 protons and 92, whoopsie, electrons. That's why there's no charge up there. But if it has a different number of electrons, it would have a charge. Okay, so mass number is protons plus neutrons, all added together because the heavy part of an atom is in the nucleus, and the nucleus is the mass number. Okay, you can hear the trains going by at my house. All right, so just again, how do we represent isotopes of atoms? We put their symbol here. Their mass number is protons plus neutrons total, and the atomic number is just protons, and you get that off the periodic table, and is neutrons. All right, so isotopic name. So I'm going to use helium. Example. So here's an example of an isotope name. Helium-8. Okay. So the symbol for that isotope be? Well, the symbol is the symbol of the element, He. Up on the top we have the mass number, and the mass number is 8. Dash to the mass, dash to the mass. So the mass number is 8, it goes on top. Where do we get the number for the bottom? Well, we look on the periodic table and we find out that the, oh my goodness, I'm just kidding. Let's call this helium-4. Oh, silly me. All right, so it's helium-4. Starting over. So dash to the mass number goes on top. So what goes on the bottom? The atomic number, which comes off the periodic table, it's atomic number 2. So this is isotopic notation name, isotopic notation symbol. Okay. So if there's no charge in the corner, we assume it's neutral. Look, it's an isotopic symbol. It's a hydrogen isotope, so we call it hydrogen 1, okay, because you dash to the mass. So this would have 1 proton, because the atomic number is 1. It would also have 0 neutrons. How do I know? Because this is the total protons and neutrons added together, and it's 1, so it's only got 1 proton. What's the charge? Nothing, so there's also 1 electron. Okay. Most abundant isotope of uranium is that one we talked about, uranium-238. 92 protons. Okay, so 146 neutrons. How do I know? 238 minus 92 equals neutrons. So this is the total mass in the nucleus minus the protons in the nucleus to give you the neutrons. What's the charge? 0. So there's also 92 electrons. Oh, look, it's an anion. It's an ion. How do I know? Because there's a plus charge. What kind? Cation. So 11 protons, atomic number. 23 minus 11 is 12 neutrons. How many electrons? Well, there's an extra proton, so there's only 10 electrons. It's a cation. Oh, look, another cation, positively charged. 13 protons, atomic number. Protons. 14 neutrons. 27 minus 13 is the rest of the nucleus. And then 10 electrons. How do I know? Because it's got a plus 3 charge. That means 3 more protons than electrons. Oh, look, an anion, a negatively charged one. So 53 protons. 127 minus 53 is 74 neutrons, because this is the total mass of that ion. So the number of neutrons and protons added together give you the mass number. And then there's 54 electrons. An oxygen ion, 8 protons. Why? Atomic number is protons. 8 neutrons. Why? 16 minus 8 is 8. 10 electrons. Why? It's got a negative 2 charge, so it's got 2 more electrons than it does protons. All right, let's keep on keeping on. We would name this helium-6. 2 protons, atomic number. 4 neutrons to add up to 6, and then 2 electrons because there's no charge. Okay, here we go. Oxygen, 8 protons, 8 neutrons, and 10 electrons. Why? It's got a charge of negative 2. You can't change proton number or it's not oxygen. So that means that in order to have a charge of negative 2, it's 2 extra electrons. Okay, 7 protons for nitrogen. No charge, so that means 7 electrons for nitrogen. And then 12 minus 7 is 5 neutrons for that nitrogen. And this would be called nitrogen dash to the mass number 12. Okay, this is 11 protons for this sodium ion. How do I know it's ion? It has a charge. What kind? Cation. So that means 10 electrons, because there's one more proton than electron. You can tell because it's positive charge. 23 minus 11 is 12 neutrons. Okay, let's keep on going. How many protons, neutrons, electrons? Well, this is chromium 52, dashed to the mass number. I look on the periodic table, I find out chromium is atomic number 24. So I have 24 protons, 28 neutrons, and no charge on it, so it's also 24 electrons. All right, neon, 20. Periodic table, I find 10 for the atomic number of neon. 10 protons, no charge, 10 electrons, and this happens to have 10 neutrons as well. Now this says ion. I know that's +1. You won't know that yet till a little bit from now, but there's 19 protons. +1 means 18 electrons, and then 40 minus 19 is 21 neutrons. All right, chloride lets me know it's an ion. I'll teach you how to know that. Yay! Chlorine's atomic number is 17, and then I know it's an ion because I know it has charge. 17 protons, 18 electrons because there's an extra negative than positive, and 19 neutrons because it's 36 minus 17. All right, keep on keeping on. We discovered it, the element of surprise. Watch out for that. Okay, how do atoms of isotope of an element differ? Well, we have isotopes, which are same element, different number of neutrons. Oh, I got an email. Different number of neutrons. Okay, so this is oxygen 16. So we have oxygen 16, 8. This is oxygen 17, 17, 8. This is oxygen 18, 18, 8. So what's different about them? Well, not the nucleus. Not the identity. They're all oxygen because they have 8 protons. 8 protons. 8 protons. 8 protons. So what's different? This one has 10 neutrons. This one has 9 neutrons. And this one has 8 neutrons. So because they're the same element but they have different masses, the neutrons make them have different masses. Okay, so these are called isotopes. They are isotopes of oxygen. Right? So what's an isotope? It's an atom of the same element that has a different number of neutrons as another atom of the same element. Now, so take a deep breath in. You just inhaled about 99.76% oxygen 16 in your oxygen sample. A little bit of what you inhaled is oxygen 17 and a little bit is oxygen 18. So can we just add all those up and divide by 3 to get the weight of oxygen? Nuh-uh, we have to do what's called a weighted average. So if you look at the atomic mass on the periodic table, it's not a whole number, it's an average mass. So if our class has a class average of 71.2356, not any one person has exactly that grade, but it's an average of all the grades. Okay, so what we do for isotopes, so average atomic mass, you have to take the mass of each isotope, so I would say mass of isotope 1, and you have to multiply by how abundant it is, percent abundance, because we don't want to we want to make it look like the one that has most, the isotope of oxygen that's the most common should be the one that adds in most to the weight. So we have to take into account the different isotopes of each element. We have to add together all of those. Now when we're done, because we use percent abundance as a percent, you have to divide it by 100 to change it back. Okay, so write this formula down as how to do it, and then let's practice after a minute. Okay, so remember, this number doesn't tell us how much any one isotope weighs. It tells us the average, but it can tell us what is the most common isotope. For instance, if you look at this, there are isotopes of aluminum that are aluminum 26 and aluminum 27. But look at this atomic mass. It's 26.98. It's closest to 27. So aluminum 27 is the most abundant isotope because the average mass is closest to its mass. All right, what about silicon? Well, this is closest to 28. All right, so I want you to decide, well, I'll do argon for you. If you look at argon's average atomic mass, it's closest to 40. So this is the most abundant. That means if you get a sample of argon, most of that argon is argon 40. So I want you to do the same thing for phosphorus, chlorine, and sulfur. Put it in your notes, look, and figure out, okay, what the most common isotope of phosphorus is. So all you do is take the atomic mass, average it to the, round it to the nearest whole number, and then you'll know the isotope that's most common or most abundant. Okay, what if we have to calculate it? Well, you take that formula we did, take the mass of the isotope times the percent of that isotope. So I plug this in my calculator, and I get 1595.2632. And I multiply these together. The average, the atomic mass of the isotope times its percent abundance, and I get 0.647324. That times that, the percent. Now this is percent, so it's already in percent. And so then we get 3.59795. You add those all together and you get 1599.508847. Now, this doesn't look like any average mass on the periodic table, and that's because these we use as percents. So we have to divide this whole number by 100 because we use those as percents, and we get 15.995. This is closest to oxygen. And if you look at the mass of oxygen on the periodic table, it's a lot of times they'll say 16.00, might say 15.9995, something like that. So that's how they get that number on the periodic table. They take all the isotopes. Okay, this was oxygen 6. I'll put it like this. This was oxygen 16. This was oxygen 17, and this was oxygen 18 from that other slide. Okay. So, isotopic, so you would do that again, get your answers, add them all up, divide by 100 to get the average atomic mass of this element. Try that, and then put in your notes what element you think that is, and we could check it. Okay, so to review, cations are positive, anions are negative, and atoms are neutral because their plus equals their minus. Their protons equal their electrons. Atomic number is protons. Mass number is the heavy part of an atom. Mass number is the nucleus, so it's protons and neutrons added together. Make sure you can write the symbols and names of isotopes. Tell how many protons, neutrons, and electrons there are. Remember, average atoms don't exist in our world. You have to multiply the percent abundance times the isotope mass, add them all together, and then if you use this as a percent, divide by 100. Hey, there he is, the hamster man. What do you think, hamster man? Was that fun? Yep, I know, you betcha. Alright, so can you do all this stuff and figure out why I'm playing They Might Be Giants? It's been fun. Peace out.